The purpose of this tutorial is to demonstrate a sample problem for use with the Texas Department of Transportation Rural Two-Lane Highway Safety Scoring Tool. The problem is going to center around the graphic that you see here, where we have a beginning mile point of 2, an ending mile point of 4.38, and in the middle of this we have a horizontal curve that's about 1.39, or excuse me, 0.19 miles long, which is equivalent to about just over 1,000 feet, and the radius is 1850. We have a variety of existing conditions. We'll come back to those in a moment, but first let's take a look at the tool. Remember, our beginning mile point is 2 and our end mile point is 4.38. So let's take a look at what we need to do here. We're going to start with the Start Here tab. And in the Start Here tab, we'll have 2 and 4.38. So those are already input for us. And the tool has calculated this next one, which is 4.38. Now, if it had been, instead of 4.38, it had been 6.38 as an example, then of course the calculated value would have been 2 more, 6.38. We'll just use that as an example just to show this. It'll automatically update, and then in the table below, this information populates as well. So here, when we told it was 2 to 6.38, it said that means, okay, you have a typical section is allowed to be 1 mile in length. It will do 1 mile length sections until it has some fragment less than a mile, or not to exceed 15 miles. So here, that's equivalent to 5 segments. And of those, there's 4 1-mile segments and 1 fraction segment, which is about 0.38 miles. For each of these locations that we have, by the way, let's change this back to the correct number, which is 4.28 or 4.38, and we'll see that we'll have fewer sections for that as well. So for each of these sections, the design critical element is the controlling factor. So for example, if you have a very sharp radius, or maybe a sharp vertical curve, or a combination of those might be a controlling element. And so you would probably have a different configuration for those compared to a road that has a tangent. So we're going to take a look at how that would work. Let's first look at configuration 1 to see what we want to do with that. So configuration 1 is the first tab down here next to the Start Here tab. Again, you can go all the way up to 15 if you need to. So here in configuration 1, just as a reminder, there's a little option up here that you can click existing, or you can click whichever element you're working on, just to get some more detailed information. Here we're going to keep it at existing because this is existing. If we want to come down and start populating the information here, by the way, you'll note that there's a speed limit. The design speed is 65 and the posted speed is 55. So there's no warnings. This warning box down here is generally refers to when the posted speed limit exceeds the design speed limit. For our design, for configuration number 1, which was again from mile point 2 to 3, I think it was. Let's look at that for a moment. From mile point 2 to mile point 3, you can see that this section of the road is on tangent. If there's no curve, the curve doesn't start until section 3.2. And so we can see that this section is going to be different than the following section. So we're going to need to have at least 2 configurations. And then the final section will be the artifact segment 4 to 4.38. Again, it's now on a tangent, so it would have the characteristics similar to what we have for our beginning section for configuration 1. So when you're looking at the startup window, that's why I have it shown as configuration 1, 2, and then back again at 1. Because this length is not an entire mile long, the score will be weighted when you do a total average score for the facility. All right, so for configuration 1, let's go ahead and complete this information. The lane widths were 11. The shoulder width, I believe, was 2. Let's just refresh our memory on some of these. The super elevation on the curve is 3.5, and a tangent is just normal crown. There's 8 driveways per mile. There's no bells and whistles on this corridor. It's a corridor that's been in place for quite some time. And so as a result, we're not going to expect for it to have a really high performing score. Primarily because when it was built, the standards were different than they are today. They didn't have a lot of the extra things that we have, like rumble strips. And so we'll see what that does to our score when we explore this. So I'm going to input this information for segment number 1. There's no curve data because that's segment number 2. No super elevation on curve because that's again segment number 2. But the rest of the information should be applicable. So the horizontal curve, we say no, there's no horizontal curve. There's a vertical curve, no. But there is a straight grade, which is 2%. So we have, which essentially is our default value for when you have relatively flat terrain. There's no two-way left turn lanes or passing lanes, so all of those would be no. We don't have any fancy bells and whistles, so all these are no. There's driveway density would be 8 driveways per mile. Now, I might point out that this is an input box that you type. Let's say, for example, we type 6 in there, for example. You'll see it already goes ahead and understands that it's driveways per mile. It just adds the value there. In our case, it's 8, so we'll put 8 in there. There's no lighting. I believe that the pavement friction factor had a value of 36, but let's confirm that. Yeah, 36. Now, if you don't have the pavement friction, which is quite likely, 36 is kind of a typical road that's been in place, but has, manageable friction. So that might be something to keep in mind. And then finally, below this, we have the roadside elements. The roadside elements were 1 vertical to 4 horizontal for the foreslope, and the back slope had a 1 to 3. And then there was a distance from the edge of lane to the lateral obstruction, the lateral clearance obstruction, that's 30 feet, and poles and trees. So all these are actually already populated correctly. So you'll see that the total score, that once we've filled in all this information, the total score that we see for segment or for configuration number 1 is 55. If we were to go back to our start here screen, we should now see that this value has changed to 55 because it's captured all this information. So we now have configuration number 1 done, so that takes care of segment number 1 and segment number 3. Let's go and take a look at what we want to do for segment number 2 here. That's going to be the section that has the horizontal curve. So again, as we're looking at this, the horizontal curve has a radius of 1850 feet and a length of 1003.2. So the other information that we changed before, we want to make sure we change that here too. It would be helpful if I typed it correctly. It's supposed to be a 10, was it 10 foot or 11 foot lanes? Let's just confirm. 11 foot lanes. All right, so this is 11 feet, 2 feet. Super elevation. Sometimes, you have marginal super elevation. You just have to manage with what you can fit in. That's what we have here. It's 3.5% super elevation in the curve. So we're going to see 3.5 here for that. Our radius was 1,850 and our length is 1,003.2. We don't have a vertical curve, we only have a horizontal curve at this location. So we're going to stick with our approach grade, which we're going to use as a value of 2. And the rest of these are the no bells and whistles options. The no's, driveways were 8 driveways per mile, That includes both sides of the road, by the way. Pavement friction was 36. As we look down at the roadside, I think that that's already been consistent with what we saw in the previous one. So here we have, just coincidentally, this horizontal curve segment happened to have a score that was similar to the segment without the horizontal curve. Now, when we go back to our startup page, we can see that that's reflected here, where configuration number 2 also has a value of 55, while configuration 1 as well did. You might wonder, well, why wouldn't configuration 2 have lower score? And I would suspect that that's because this is already a pretty low score, and so as you get lower and lower, the chances of moving down a full number start getting reduced. Just as probably when you get up to close to 100, the chances of increasing by an entire number, those probably diminish as well. If we scroll down and take a look at the end, or the bottom of this table, you'll see this is the weighted total score. I could have guessed that without looking at it because all of them are 55, so this one happens to be 55. But if we had had something different, it would have adjusted for that as well. And then it's, of course, got the same thing for the others. You can see that as compared to the standards, this one is not performing very well. Again, this is standards for today. This one's probably constructed in standards for yesterday, many yesterdays. And then the optimal value is typically going to be 100. That would be the ideal condition with all the bells and whistles. So that concludes our demonstration of how you do a sample problem in the scoring tool spreadsheet. Thank you.